This fourth passage was interesting. It debunks a myth that I totally had bought into. I had no idea this wasn't true. As a matter of fact, the last house I owned was built in 1890, and it had those windows with the Ripley glass, and I absolutely thought that it was because glass flowed. And I am sharing that with you because I trust you not to laugh at me. Glass is not a liquid. I mean, yeah, conceivably it could exhibit some of that drooping effect if you gave it, what, a period well beyond the age of the universe? No, instead, the differences in thickness result from glass manufacturing methods. You had to blow it and into a bubble and then flatten it into a disc. And that just resulted in an imperfect thickness. All right, the main point of the passage, everything we just said, that contrary to popular opinion, which is just false, glass is not a liquid, it does not droop. That would be stupid to think. Instead, the rippling that you see in old windows is because of glass blowing methods. And there's your answer choice E. For 22, where does the passage answer one way in which 19th century window pane manufacturing techniques differ from those commonly used today? It does so in the entire last paragraph, right? Explains the way you used to blow it into a large globe, which we already talked about, and then today in line 55 you float it on molten tin. It's interesting. And that's what we have to have, right? In order to choose something as an answer that answers the question, you have to have an answer to the question there. For 23, a summary of the author's view of Zanotto's study. It was good, right? But specifically, how do we prove A, that they provide data to support a view that was already held by scientists? Well, we support it when the author says it. I'm in line 40. The study demonstrates dramatically what many scientists had reasoned earlier. And the textual support, And for 24, it's interesting because we just pick up right in the same sentence where we were to answer this next question. The atomic structure of glass is such that it will, D, flow downward if it's heated to glass transition temperature. Where do we say that? Well, we say that in line 42. For glass to have more than a negligible ability to float, it would have to be heated to at least 350 degrees Celsius. For 25, the author attributes the belief to the assumption that glass's structure causes it to behave like a very viscous liquid. And she attributes it explicitly in line 4, the belief that glass flows slowly like a very viscous liquid. There is an author attributing a belief to somebody. For 26, another analogy question like we saw in the first passage, and we deal with it in the same way. It's got to be derived from what the passage did. Who cares what who cares what they're going to bring up? I mean, it's pottery here, but it could be anything. What it has to do is what's important, and what it has to do is give us an example of a time when somebody believes that something is a certain way because of its inherent properties, when in fact it is that way because it was made that way. They think that glass has this inherent property of being like a really viscous liquid, but really it's just it was made imperfectly. B, the exact same thing. The flaws in pottery are caused by the material, but in fact they were caused by the manufacturing process. For 27, how do we know that the upper extreme of the transition temperature of glass is well above 350 degrees Celsius? Well, we know that because in line 44, line 43, I guess. I don't know why I characterized it as 44 or whatever. That was very lazy. Let me be precise. In line 43, the author says it would have to be heated to at least 350 degrees Celsius, right? So that's the bottom end of the range. And also in line 16 or whatever, and specifically line 17. No, it is actually line 16. It's typically a range of a few hundred degrees Celsius. So if the bottom end of the range is 350 degrees, at least that hot, and the range is typically a few hundred degrees, then we know C, the upper extreme, is well above 350 degrees. And that finishes this passage, and that finishes this section.